Okay, dear students, let us continue with our problem. So, in the last session, we stopped with finding out the value of H1. We found it out. We found it out as 401.07 kilojoules per kilogram. Now we need to find out the value of H4, which is nothing but H3, and which is nothing but HF value at 35 degrees Celsius. So again, let us consider our data book. So to find out the HF value, okay, so we are going for the 35 degrees Celsius column. So we are taking the next page of the table to let us find out the HF value corresponding to the temperature 35 degrees Celsius. Correctly, the 35 degrees Celsius value is not given, but we can interpolate the values for 34 and 36. Okay, that is 241.84 and 244.844. So we can interpolate. So we can interpolate the values and find the value for HF at 35 degrees Celsius as 243.14 kilojoules per kilogram. Don't forget to always write down the kilo unit. Here it is kilojoules per kilogram. Now our first portion, it is over. We have found out H1 and H4. Already in the last session we have written down this relation. Refrigeration effect is nothing but 50 kilowatt, which will be equal to m dot into H1 minus H4. Okay, so we can write this the refrigeration effect, which will be in the refrigeration effect, which will be in kilojoules per kilogram. It will be in H1 minus H4, that is without this m dot, that is this value difference value, and it will be 157.93 kilojoules per kilogram. So that is our first part. The first question was to find out the refrigeration effect in kilojoules per kilogram. So the refrigeration effect in kilojoules per kilogram we have already found out as 157.93 kilojoules per kilogram. Okay, so the next question, the second part of the question was to find out the circulation rate of the refrigerant in kilogram per second. Okay, circulation rate of the refrigerant means what is the rate at which this refrigerant or the working fluid is moving or flowing throughout our refrigeration system, and we need to find that in per second value of kilogram or kilogram per second, or they are asking us to find out the mass flow rate of our refrigerant. That is very easy. We have already written down the relation for refrigeration effect like this: 50 equals m dot into H1 minus H4. H1 and H4 we have already found out. Okay, so the only unknown term here is m dot. We can cross multiply 50 by H1 minus H4. That will be nothing but 0.316 kilogram per second. Okay, so now let us move on to the third part of the question: power required by the compressor in kilowatt. Okay, so where is this compressor working coming? That is during 1 to 2. That is from 1 to 2, isentropic compression 1 to 2. So 1 to 2 process is represented in our pressure enthalpy diagram also. So what is the power? The third part of the question is to find out the power required by the compressor in kilowatt. So that is also very easy. How we can find out the power required by the compressor? That is nothing but the work done by the compressor, and that is given by H2 minus H1. That is simply find out the enthalpy difference from 1 and 2, H2 minus H1. Okay, so our compressor working will be H2 minus H1. This will be in kilojoules per kilogram. If we multiply it by mass flow rate, this mass flow rate will be in kilogram per second. So the net effect of this m dot into H2 minus H1 will be in joules per second or kilowatt. Okay, but please wait. Now let us consider this H2 minus H1. Okay, but H1 we have already found out, that is G value. H1 we have already found out, Hg value at minus 10 degrees Celsius. Okay, but what is the value of H2? What is the value of H2? Okay, in order to find out that, again let us consider our pressure enthalpy diagram. So what is the condition of the refrigerant at 2 it is actually a superheated state of the refrigerant. Okay, at 2, the nature of the refrigerant is in its superheated state. We do not know the value of enthalpy at that superheated state. Okay, and also we do not know what is the temperature of the refrigerant at 2. Okay, so for that we can write this relation: H2 minus H2 dash will be equal to CPV value at 35 degrees Celsius into T2 minus T2 dash. Okay, so how did we write this relation? Actually this here we are not writing anything new. We have already found out, we have already learned from our junior classes like this. Enthalpy difference will be equal to Cp delta T. Here we are writing that only. Okay, so that is enthalpy at 2 will be equal to enthalpy at 2 dash plus Cp delta T. Delta T will be T2 minus T2 dash. Okay, if you can remember that, it will be well and good. Or otherwise you can refer the notations page, the notations page of our data book. Okay, so now let us refer our notations page of our data book. This is our notations page of our data book. In my data book, the page number is given as Roman numeral 10. Okay, so this notations page is coming at the initial sections of our data book of the CP Kodandra Amman data book. So the various notations, various notations followed in this data book, and the explanation are given. Okay, so when we read through that notations, here it is given: for the superheat region, use the method as below. Okay, here they are mentioning about the specific volume. So for the time being we are not using that, but you look at here, H will be equal to Hg plus Cp value of vapor, Cpv. P stands for constant pressure, V stands for vapor condition, specific heat at a constant pressure and at the same time for saturated vapor, times T minus Ts. But what is this T and Ts? T will be the actual temperature in Kelvin. Okay, so this will be the actual temperature in Kelvin, and Ts will be the saturation temperature in Kelvin. So so here when we are applying the same to here in our 2 dash and 2. Okay, 2 dash will be the saturation temperature, saturation point. 2.2 will be the actual temperature in Kelvin for the superheated state. So by applying this relation, H is equal to Hg plus Cpv into T minus Ts, in our case we can write this relation: H2 minus H2 dash will be equal to Cpv value at 35 degrees Celsius times T2 minus T2 dash. Okay, so what is this H2 value we have to find out. Okay, so what is the value of H2 dash? H2 dash will be nothing but Hg value at 35 degrees Celsius. How did we find that one? Again, look at the pH diagram, pressure enthalpy diagram. What is the condition of the refrigerant at 2 dash? It will be saturated vapor state. So H2 dash means it will be Hg value, but corresponding to which temperature? What is the temperature at 2 dash? So again we have already marked it. Okay, in the earlier section itself we have already marked it. The temperature at 2 dash and 3 will be nothing but 35 degrees Celsius. Okay, so that is why this H2 dash will be equal to Hg value at 35 degrees Celsius. Okay, so again we can find out the Hg value at 35 degrees Celsius. Okay, so again we can refer the data book. We can go for this 35 degrees Celsius. Okay, 35 degrees Celsius. So Hg value, okay, Hg value, it is coming like this. Hg value corresponding to 35 degrees Celsius. The correct value is not given for 35 degrees Celsius. We can find out for by interpolating the values for 34 and 36. That is, take the average of 414.79 and 415.18, and that is given here 414.985 kilojoules per kilogram. Okay, always please note, be careful about the units. So by substituting it here, H2 dash we found out Cp value at Cp value of vapor at 35 degrees Celsius. Okay, so that is the next part. How to find out the Cpv value at 35 degrees Celsius? Fortunately, in our question, it is directly given. But suppose if it is not directly given, how we can find? So again, we can refer back to our data book. So the last column. So the last column is specific heat value. That is, it is separately given for liquid and vapor. Okay, so here we want the Cpv value, that is specific heat constant for superheated state or vapor value. So we can go for this vapor value of specific heat, and we can find out that value for 35 degrees Celsius. Actually, it is not directly given, so we can interpolate for this values 0.952 and 0.97, and that is nothing but 0.96, and that fortunately in our question that is directly given. Okay, then the T2 dash value we have already marked in our TS diagram. T2 dash is nothing but 35 degrees Celsius. Okay, but what is this T2? Suppose we want to continue with this relation and find out the value of H2, we need to know the value of T2. But what is this T2? T2 value is not directly given in the question. We do not know the temperature at T2. So how we can find the temperature at T2? For that, again, we can write a beautiful relation like this. S2 minus S2 dash will be equal to Cp V value times natural log of T2 by T2 dash. So if we can remember this relation, that will be very good. Otherwise, we can again refer to our notations page. Again, if we are looking at our notations page, the notations page, again it is given for the superheat region. You can use the method as below. Again, they are written. They have given the method to find out the specific heat values. So S will be equal to Sg plus Cp value of vapor times natural log of T by Ts. So T is nothing but the temperature at the superheated state, and Ts will be the temperature at the saturated vapor state. So substituting this relation, that is S is equal to Sg plus Cpv value at and times natural log of T by Ts in our relation. So this is how it will be coming out. S2 minus S2 dash will be equal to Cpv value times natural log of T2 by T2 dash. So what is this? What is this S2 dash? What is this S2 dash? So 0.2 dash is the saturated vapor state. So we can easily find out the value of S2 dash as Sg value at 35 degrees Celsius. Okay, so we can refer to our data book. We can find out. We can take the tables corresponding to 35 degrees Celsius. Then take up the value for Sg value. Directly it is not given for 35 degrees Celsius. We can interpolate for these two values, and that is given here, the interpolation value, and we are finding it as 1.7037. Actually, we need to consider the unit also. It will be in kilojoules per kilogram Kelvin. Okay, so we have now stopped at S2 dash. So let us continue later.